What's up, peers, and welcome to Open Source Everything, back to back, here with another show live on the World Crypto Network. We have just finished up last conversation with Nopara and with Michael, both respectively from Wasabi Wallet and Nodl.it, full open source, privacy focused wallet, and a full open source Bitcoin and Lightning Network full node. So really cool subject that we talked about here. And now we are joined by Jan Kapek from Slushpool, and we have already talked to him on during the Baltic Honey Badger conference in Riga about Braiins OS and its open source mining software. And we're going to expand the conversation today. So Jan, what's up? How are you doing?
Yeah, I'm pretty good. Pretty busy day for us. So where do we start?
Well, good question. Well, let's start with a tweet that you published at the Braiins Twitter account. It was that the Antminer S9 is actually capable of supporting overt Asic Boost. Overt Asic Boost. However, the functionality is disabled by vendors and FPGA design. We want to enable it. That's a declaration of open sourcing everything, so that's nice. So what's going on with that tweet? Yeah, what is that?
Okay, so well, we started this adventure probably sometime last year in fall when we were starting, digging into like mining firmwares and looking around, and we just found out that this was like the major cause of problems. That the fact that the firmwares were closed sourced, we had to constantly fight some incompatibilities, bugs, and deploying various workarounds for all these things. And as I have explained, I don't want to repeat myself from our last interview, but basically we decided to fix this issue in the software stack by extending the range of services that we provide. And that would be trying to come up with an open source firmware that would work like seamlessly with our pool, but at the same time, you can just hack it, you can play with it, you can just direct it to whatever pool you like. But this would be like a courtesy service to our miners. So this is how we started. And then we decided like what hardware devices are we going to support? And the two major devices that are out there were the Dragonmans, and there were the S9s, which are like the most popular ones currently. Things may change obviously in the future, but for the time being, it was like that. And so we tried to pull all the bits and pieces from the internet that were open sourced for both of them, and mostly for the S9s, and tried looking into what can be done to really make it like integrated so that not like a hardcore embedded software engineer is able to build it. So we came up with the idea of building the whole thing on the OpenWRT distribution, or LEDA as it was last year called. And having this ready as a basic platform, we wanted to look into how the mining software, so the CG miner implementation, works on S9. And when looking into it, we came across various traces in the source code and also on the internet about Asic Boost and the capabilities in the, let's say, in the hardware, in the chips. So we tried verifying like all these different claims, because people like to talk about things, but they don't like to verify like how things work really internally. So we were deeply into the software, like looking what features are implemented, and it just looked like that the FPGA code, and maybe I have to branch off a little bit to explain like what an FPGA code is, but we found some traces that the hardware itself would be capable of doing something like an overt Asic Boost, which in our case is implemented by touching the version bits. Because what happens is if you enable Asic Boost in your chips, the SHA-256 function, and I'm going a little deeper now, has the first step, which is called an expansion, and then it's doing the compression, which is like the actual hashing. And it turns out that the nice thing, if you read the Asic Boost paper, is that this expansion step is not dependent on anything that the hashing function did before with previous chunks of data. So having this expansion step shared by the silicon, you can save some energy. So it's a really cool feature that I think Sergio and Timo Hanke came up with. And the idea is like really smart. The way it's done in silicon is up to the ASIC engineers. But again, by looking at all these different traces and little things in the code, it turns out that the chip should be able to do it. So we tried working with the software without like really modifying it too much, and we forced it to do actually version rolling and enabling the Asic Boost, so sharing the expansion step, and we would see some reduction in power consumption of the whole mining hardware by something between 9 and 13%, depending on how many states you try to roll or how many version bits you try to roll. But the problem was that the results were valid from proof of work perspective. So if you did the hash calculation of the result that you got, the nonce, it would be correct. But the problem was that the version header, so it's the first field in a Bitcoin block header that the software tries to touch, was invalid. So all the proof of work that has been done is something that you can throw away. So technically it worked, but it was not usable within the current consensus protocol because you could not be submitting valid shares to the pools, and in turn you could not submit valid blocks to the network because it will be rejected by a simple fact that the hardware was touching the wrong bits in the version field. From software perspective, this looks very simple. It would be like, okay, let's just fix it and touch the correct bits. But now the real problem is the FPGA, and I have to explain a little bit about the architecture of the miner. The miner itself, in case of S9s, it consists of a control board, and the control board has a CPU, and it also has an FPGA, which is like a gate array, but it's programmable. And people start talking about this thing called bitstream, which is basically a binary program in a very simplified way that describes how the gates are actually connected in this FPGA. And the problem is that you are not able to simply reverse engineer this bitstream. So it's not like with a software where you can disassemble a program. You have to basically, there are some ways how to do it, but it's very complicated and it's very expensive. So it turns out it's more simple to start writing your own bitstream, so your own source code, and try to compile these connections of the gates. So the fix itself would be simple if you had the bitstream source, which nobody is going to give us, probably, who knows. This is basically what the tweet was about. We have announced that we have verified this functionality, but it is not usable in production Bitcoin mining. What can be done is either make the manufacturer to release this feature, or we will be working on our own bitstream in the meantime.
So is it really just a lacking information? So is there something that is held back by Bitmain in its closed source code? And is it that information that is lagging, or just some tweaks to the software in general?
Well, I would say it's what is lacking is what was lacking. It has changed today, but what was lacking was the source for the bitstream or a fixed bitstream. So a fix for that problem. And the problem is that it looks like that it may have been disabled intentionally. And I think Bitmain actually stated this in their blog post, I think a year ago or something like that. The one that we have referenced in our tweet. They basically say we're not going to make this available to general public. but they didn't say that they were using it themselves. So it's hard to say, like, are they or not? I mean, I don't know. In case of the Avert, there were not too many other ASIC boosted blocks before, or there were none actually, before the Dragonman's T1s went out. And now these days it's hard to tell apart which blocks come from S9s and which could come from S9s and which come from Dragonmans. So what was missing was the source or a fix from Bitmain. And like today, they have released a firmware that may have a new bitstream that should not have this problem. However, they didn't release the sources for either of these. So we don't have the source for the Bitmain for the BM miner, and we also don't have the source we don't have a source for the bitstream.
So the problem was a lack of transparency,
right?
And then they remove one part of the transparency, but hold back a bunch of other information while still retaining the closed source aspect. I mean, that is not really a fix to the solution, right? That the ecosystem here is having. So do you think that this move of making the software now even more closed source, does that make sense in any way?
Generally they try to make some business decisions, and for them it looks like that this is the best business decision to be made. But the problem is that we already see other manufacturers coming up with more powerful chips. So when this would be relevant, if not now, if let's say M10s have like 65 watts per terahash, and without Asic Boost, you are somewhere around 90 something, 100, whatever, watts per terahash. So you're not already competitive anymore unless your electricity cost is super cheap or super low. So if you improve this by 10%, you should be able to run this hardware for a little bit longer before the other technology, takes over. It all depends on the majority of the hash rate, if it's on the newer technology or if it's not. So you still have some limited window where you can use this feature. And the sooner it's available to the general public, the better. So that, like all the mining parties can play the same game, sort of.
Interesting. And so you spoke about the Dragonmans, and does this type of hardware from a let's say more transparent company, does this type of hardware have the same issues as we have here with the Bitmain S9?
Well, the Dragonmans are, I would say, more simple in a way that the bitstream we already have an open source bitstream for Dragonmans, because it's essentially only a set of peripheral drivers for SPI and PWM, the pulse width modulation. So supporting that hardware was much easier, whereas with Bitmain chips, it's the problem is that you don't have all the specification also for the chip. So you have to gain all the knowledge from the sources that you see in CG miner backend drivers, and you're still sort of like guessing like what the FPGA might be doing to the chips. So the situation is slightly more complex, and even more. And this, what makes people, I think, a bit suspicious, is that the FPGA bitstream, I don't know if it's still valid, because I didn't see the sources for the CG miner now, but the previous version was doing a lot of logic. So it was essentially building the whole Merkle root. Like, when you assemble a block, you have to take your Merkle path, and you have your Coinbase, and you have to come up with a Merkle root. So all this logic was not like naturally you would implement this in your software and just have your FPGA, prepare little tiny bits of the mining jobs and send it to the chips. But instead of that, the FPGA was really doing quite a bit of logic. So the CG miner driver was essentially not doing much, letting you like really guess what the chips can do. You could hide away a lot of capabilities of the chips just within the FPGA code because it's really doing everything, or was doing everything. I mean, I don't know if it's still valid. So yeah, I mean, maybe because it's been released today, maybe tomorrow we'll see the sources for the BM miner. It's going to come up to GitHub. I hope so. It should make our life easier. Because I mean, I don't think this is like a negative thing. Any activity that we do on this end still sort of boosts the sales for Bitmain, right? I mean, if you can improve somebody else's product, people are going to buy it, maybe.
Well, yeah, right. That what actually should be the logical conclusion, to be like, hey, this gives all our customers all of a sudden 13% more reason to buy our products. That should be perfect. But might it be possible that this overt ASIC boost has been either done by Bitmain themselves on their own mining hardware, or by Bitmain customers in their own pool?
You mean before, in a way that nobody knew about this? Well, I'm kind of sure that with our finding, we were not the only ones looking into this. I mean, people were talking about this on Reddit. I mean, I didn't find like any really deep technical discussions that would, like really dig into details like what the FPGA might be doing, but there were some indications. So I'm sure that there were companies really giving their time to develop some custom firmware, but they would probably use it for themselves. I'm sure there are companies out there that do this, or some groups of miners or whatever. I don't think that this is the only initiative happening. But maybe this is the only open source initiative, I would say.
Well, and hopefully not the last. Let's make sure of that. So when you at Slashpool and Braiins OS would release the software that is capable of releasing the ASIC boost and gaining these 13% additional revenue or efficiency, what would that do to you as a mining pool offering that, and of course the software itself? Do you think that this is further going to increase usage?
Well, for us, it's again, it's sort of like a marketing thing, right? We try always to be the good guys. So our business model is that we provide the firmware and we provide the alternatives. Similar, like we came up with the Stratum extension for version rolling the BIP 310. So we do this in a hope that some of the hash rate would land within our pool, and the rest is up to the miners. I mean, this is our policy, so we try to stay very consistent with this, like staying on the bright side, I would say.
Oh yeah, that is really nice and really very much needed. So do you think that this push towards more open source and more, let's say, ethical mining will continue to happen, or do you see more of the let's say cold hard business deals?
I think it's if there's an added value to this, I'm sure it's going to happen. I mean, again, taking the example from the embedded devices that use OpenWRT, like why do people actually install OpenWRT into their routers? Why do developers give their time to this project? And the answer is they want to be sure that their routers at home are not, being part of some botnets and some malicious software, and they have to be auditable and so on. So what we try to do is we want to provide Braiins OS as a platform, and we expect that the community sort of absorbs it and also gives something back to it. So we sort of expect that a community around the whole project could build up a really nice traction And the more developers that this whole thing has, the faster we can proceed. Obviously, like future plans would be doing support for some ASICs for altcoins that used to be like GPUs, or even like supporting some GPU mining and having it as a common platform for the community, whatever, like really you name it, what you want to do with it. So we want to give the community our knowledge that's in the form of the Braiins OS thing, which every embedded systems engineer can really catch up with. It's like it's really nice to have it in one place, but at the same time, it's no magic. I mean, it's just software. It's integration of few bits and pieces. And I mean, OpenWRT is a huge piece of software because it's actually the thing integrating all the different softwares and making it into a full-fledged embedded Linux distribution. And we're contributing just with little things like the miner software integration and FPGA bitstream and so on. So, I mean, we'll see what happens in the future. We definitely don't want to do all the work on our own. I mean, so actually we have a pull request, I think, or somebody already identified some little thing in the Dragon Mint bitstream. So that's going to get involved. And like, what is nice is people actually take their time and they find their time to dig into these things. I mean, I don't know too many people that like to read FPGA code. So it's really cool.
Well, and that's the power of being open source, right? Is that even if one individual on the complete other side of the world is interested and wants to provide his support, maybe because he's using the software himself and he finds these little bugs and optimizations in the software, then he can do it, and there are no barriers to entry. So, yeah. Do you think that this will mean in general that Braiins OS will be a more superior firmware assisted software than the closed source Bitmain?
We'll see. I mean, this would be our wish, and we'll see what happens in the future. Because so, I mean, it's not about replacing the factory firmwares if they were like top quality, but the problem is if you look at it, like, I mean, people are used to some industry standard when they use the Linux distribution, right? Like, how would you like if you had to download some binary thing on your computer and you would run it as a Linux distro, and then you would have problems like installing packages? I mean, I don't want to compare like mining hardware with a desktop. It's a different story. But in a certain way, it's very similar. Like, there are certain standards in the industry that actually save developer time. If somebody is going to do some development work on the miners, I mean, you don't know what the farms want to do with the miners. They have their own monitoring softwares. They want to have their own proxies. They want to do whatever integration. And if the environment where they have to do this is standard, it's going to make their total cost of ownership a little bit lower than if they have to hack every little thing. And this hack is going to stop to work with every new release or with every manufacturer's firmware. So this whole idea is to try to bring something that would be an industry standard.
So yes, these industry standards are extremely important, and that's what we have. You know, something like BIPs and everything. And what you also tweeted out is that Bitmain, or that users should not upgrade their S9 devices with Bitmain's firmware because it's not compatible with the BIP31 standard, and thus it is not compatible with the slush pool. And you're of course fixing that right now as we speak, and hopefully the fix will be online very soon. But what exactly is going on? Why is this BIP3010 standard broken by the Bitmain firmware?
Well, we did the analysis today, and it looks like you know, the BIP 310 is all about negotiating the features, right? Yeah, are we online still?
Yes, we are.
Okay. So BIP 310 is all about negotiating the mining features, and One of them is that the miner actually tells, okay, I can do version rolling and I can do it within this mask, and I need to roll this many bits in order to be efficient. And the pool responds, okay, you can roll within this many bits and go ahead. This is your first mining job. Now, the problem is that the firmware, when it actually starts submitting the results, it doesn't say which bits it has been rolling. So every result is actually missing this information. And the pool, our fix is going to be that the pool is going to sort of guess which bit it was trying to touch and verify its mining results. But the standard actually requires that with your submission, the miner is, or the submission, the miner is always required to provide the version bits that it actually used to calculate the result. So our workaround is effectively also not complying with the protocol, but for the time being, there is nothing much that we can do about it. So we'll try to be a nice guys again and support even the broken firmware for some time.
Can you issue your own pull request to try to fix it?
Well, the problem is that I don't know where to issue the pull request. If you look at Bitmain's BM miner repository in GitHub, it's probably 2 years old or something like that. So it's not very live. And effectively, I don't know where to really where in the code to issue the pull request to, because obviously they must have been doing some development on the software itself. So
what percentage of your users do you think are going to upgrade? Because we've seen with Bitcoin and the SVE bug that it took quite a while before full nodes updated. So how fast do you think is a update process for you as a firmware for the miner?
Well, from what we know, the big farms are usually pretty conservative. But since we are deploying the fix tonight, I mean, I have no problem if they start doing it tomorrow. So we should be good.
Okay, perfect. And maybe that as a quick aside question now that we talk about updates and regarding especially the bug that happened with and was fixed with the version 16.3. And in the official disclosure by the Bitcoin Core developers group, they mentioned that they first stepped up to you to slush pool with the fix and with the problem. So maybe could you just give a brief overview of how these couple days were from your end and how involved was slush pool and what did you do?
Well, essentially, before the disclosure, we've been contacted by the core developers with an urgent request to upgrade our Bitcoin nodes, and we've been pointed to a patch, which was like I think it was a pull request or something like that. It was published in the official repository. I think we've received the patch separately, but the patch was very simple. So it was very, very easy to review what it's doing. So we basically built. We never run our full nodes from a binary downloaded somewhere on the internet. So we always have to build it within our secure environment. So basically, we just built a Debian package and deployed it on the pool. That's it. Like long story short. But before that, we've been discussing things with the core developers. I think it was Matt Corello who contacted us, and like they tried explaining like what the details were and why this is necessary to be deployed. So I mean, this is protection of somebody else's wealth as well. So we had no problem like deploying it immediately.
Okay, very nice to hear the rigor in the code review and in the building the source code, which is important, and nice that you took that initiative and reviewed it first, but then swiftly deployed it.
Yeah, it was really like one-liner. I mean, if it's really worth looking at it. It's just switching true to false or the other way around. So it was really nice. When I first time saw it, I was like, well, this can be a fix. But then we looked a little deeper and it just made sense. So
well, that's the crazy thing about this consensus software. Even like this, or a consensus network, even a small 2 lines of code could have potentially horrific, dangerous effects.
yeah, the most expensive patches are one-liners.
Oh yeah, absolutely. But they are also the worst pickup lines, so don't try that. Well, so now that a couple weeks have passed since that patch, and of course now even version 17.0 is out, which you should be running on your full node.
Yeah.
So how do you, or what do you think about the upgrade process of the network? Because still many are susceptible to the bug.
Well, to me, this is something that I don't understand why people wouldn't do the upgrade. But the problem is that I think it's a problem of incentive. Like nobody is going to run the attack now because it would not be really efficient in a way that the majority of the network is already switched, I would say. So, I mean, I think there are tons of nodes out there that nobody really maintains that often. Who knows?
No, hopefully not. Upgrade your node and run a node. That's the first step.
People should run their nodes, yeah.
Yes, they should. You can run one on your phone, AV Core, download it. Waste a ton of battery, but at least you got your financial sovereignty in your pocket.
Oh, yeah.
Well, one question I still have regarding Asic Boost specifically is that I thought that with one of the big updates of Bitcoin back in 2017, the segregated witness update, that due to the fix or to the removal of the witness from the transaction script, that this actually prevented Asic Boost. So do we have something messed up, or how is segregated witness affecting Asic Boost?
I think the problem is that there is a commitment, right, somewhere in the Merkle root. And this prevents an efficient way of shuffling transactions. Because there are like 2 ways of doing Asic Boost. One of them is the overt one, which is like the obvious one where you can touch some data in the first 64 bytes of the Bitcoin block header, which is altogether 80 bytes. So the SHA function is actually hashing 2 chunks of data. And the first chunk is always hashed outside of the silicon, so generating something called mid states. And these mid states are being loaded into the mining hardware, and this is doing the iterating and grinding the nodes and maybe touching in time and so on. So the overt is easier in a way that you can touch one specific field in the first chunk in the version field, and then you get your misstates. To do it in a covert way, it means you have to come up with a new Merkle root, because 4 bytes of the Merkle root are actually part of the chunk too. So what you have to do is you have to generate some combinations of transactions within your Merkle tree that have actually a collision in the last 4 bytes that spill over to the second chunk. So before SegWit, this was easier, that you could do some shuffling and it would be still valid. And the point was that you wanted to reduce the number of Merkle root calculations to the bare minimum. So otherwise, it would not be worth doing it. To find the collisions, it would be just too difficult. With SegWit, this has changed a little bit. But from discussions with some core developers, there should be a way still to do it, which was actually on our list to come up with some proof of concept of showing like how to do it. And the main reason was that people would actually be sort of repelled from implementing it, just to see the proof of concept. Yeah. I don't think I'm able to provide like enough technical details in how it can be done with the current circuit. It's a little bit out of my like technical knowledge right now, because we've been focusing on other things lately. But from what I know from other smart people that spend their time with Bitcoin development, they say it's still possible to come up with some really cool algorithm. So it's a nice engineering exercise to do this. And obviously, you would have to offload this to an FPGA. You could not do it like on a physical miner. You don't have enough computing power on your CPU, but it could be possible to come up with some IP core that you could synthesize and download into the FPGA. There should be enough space for it. For example, on S9s, where you could do something like this. But again, I mean, we have our Asic Boost. Like, why would you waste your engineering effort on this? No. Unless somebody would like to bend you over it, but it's not going to happen, I'm assuming.
Okay, and so in general, is it good to have ASIC Boost? Does it provide more hashing and therefore more security to the proof of work blockchain?
I think the right answer is if it is good, if everybody can access the technology. And I think that's the point. Like with mining, if you want to have balance and also an economical balance in the system, I think the ASIC Boost, if it's possible and the protocol allows it, which obviously just by design it allows it, it should be accessible to everybody. So this is the way I try to think about it. If you mean that people that actually save this 10, 9, 13, whatever percentage of their power, if they're going to use this power for hashing, obviously yes. And then the answer is we could see some rise in the hash rate, or people could try overclock their devices and actually use a little bit of the energy that has been saved. But I don't think this is actually really working in a linear way. So there could be a little bit of rise in the hash rate, but I don't think this is like the major impact. The major impact is that the distribution of the power, and I don't mean power in terms of electricity, but I mean of hashing power, should be the same like for everybody. So if there is an ASIC Boost feature in those devices, it shouldn't be that some group of people can use it and some other cannot do it.
Right, because the security mechanism of Bitcoin fundamentally relies on the percentage of hashing power that a malicious actor can accumulate. And if there is a malicious actor that he's the only one that knows about ASIC Boost, that gives him what the 13% increase in efficiency. And that would make it much easier for him to accumulate more of the hashing power, and thus might have the ability to reorganize transactions on the blockchain. And that emphasizes the importance of having this stuff open source, because only then do we have complete, true, free ownership of all these information for everyone, and a sharing of this information. And that is ultimately what is absolutely needed.
I believe the ultimate setup would be if we had an open source RTL, like the register transfer logic for the chips, and essentially having some blueprints that people could theoretically use to produce their own chips. I mean, this is a little bit naive idea, but I could see bigger groups, foundations that could take advantage of this. Because even with the open source things that we try to do, the chips are not open sourced, and they're very hard to analyze in terms of the functionality. Like, I mean, big ASIC houses, they can do it. They can really verify that the chip is really doing what it was supposed to be doing. But again, this is a little bit wasteful effort. It's like as if you tried to verify that your binary program is really controlling your washing machine instead of looking at the sources and compile it and running the binary thing. So, but with the chips, the problem is that this is a very tricky area because you're facing some really expensive intellectual property, standard cell libraries that the foundries use, and so on. So I can see a future where the RTOs for the chips would be open sourced, but it's not that easy that everybody could actually review a physical hardware design, like what is synthesized on the silicon. So I'm just trying to emphasize that the problem is not solved just by having the first parts up to the FPGA. Some miners don't even have FPGAs, but like the major, like the software parts open sourced, because you still have the silicon. And if people do remember the latest Supermicro issue with the Chinese bonus chips, this is kind of like similar.
And that's why projects like Purism are so interesting, building a completely open source hardware laptop and phone and tablet. And do you think that this drive towards even achieving more transparency for the hardware is going to continue? Or are there other interesting projects that are working on truly liberating the information of hardware as well?
I think this is definitely the future, because the level of spying of all the national agencies all around the world has reached a certain unacceptable level, I would say, and people would like to verify that they use technologies that they trust or that they can trust. I'm not saying this is going to happen with the majority of the population, because I mean, like if you look at the way how we live, we're becoming like more and more like consuming society, right? It's easier for people to go to Walmart or somewhere and buy whatever piece of electronic equipment you need at this time. I don't think that these people are going to care about verification, but maybe like today we have some stickers on food saying like this is GMO food. This food is certified and so on. We could have something like this on electronic devices saying like this has been audited and is whatever open sourced. I don't know, like something like this, like certificates of transparency, whatever. So I think this could be the future, but definitely it's not the future for like the majority of the population, because not everybody is a computer geeks like we are, right? Trying to look into things, how they work, and play with Linux all the time and so on. But it could be that there would be certain proofs or certificates that even people that are non-technical could just look at and trust that if this device has this signature, whatever that means, if it's a sticker or whatever, some digital signature, I can trust it, I can use it, I don't have to understand how it works, because I'm sure that the community that's behind it, that built it, or the company, is enough transparent for me that I can trust it.
Absolutely. And so do you think that that stuff like, for example, the Librem key, which is a USB security token, which does do encryption, key management, and especially tamper detection. So how it basically works is that you plug this USB stick into your device, and it checks if the binaries of the software or the wiring in the hardware has been tampered with. And if not, it's going to shine a green LED. If yes, it's going to shine a red LED. So is it possible to have some sort of a security token for tamper detection in mining hardware as well? And is that useful?
It depends if... with the mining hardware, like the worst thing that can happen is that you have some hidden hashing power that is not used for your mining account and goes towards the attacker, right? So the discrepancy would be that, okay, you are buying a 14 terahash miner and what comes to your home is something that performs 12 terahash. So it's pretty easy to verify that there is some difference, and you're going to look why it's by 1/6 different than what, so 20% or 15% different than what you were expecting. You're not going to use your miner for talking to your parents or signing your emails or anything, doing a GPG on it. So I think that with a security, you probably need to be able to detect the tampering part, which if the current miners were following the standard Linux distribution standards, like with Ubuntu, you have all the packages signed. I mean, obviously, if the central Ubuntu repository is compromised or Debian is compromised, then we have a global problem. But we have to assume certain things, right? So assuming those things have not been hacked, or those parties have not been hacked, I can easily verify that a computer that came to me has the right image installed, right? So I think this is the level or the degree of tampering detection that I would probably see with mining hardware. I don't think you would really need some dedicated token that would do this. I see a use for this kind of token if you want to verify that your laptop has not been tampered because you left it in your cafe. But with mining hardware, one thing that you have to make sure is that your network is secure, because the mining hardware is operated in big farms. There's like tens of thousands of machines for bigger operations, and it's really your responsibility to secure your building and to secure your network. It's not up to every single device, because then you're dramatically reducing the usability of the device, because you cannot think of a miner as like one box sitting on your desk. You have to think about 20,000 boxes sitting somewhere in a big hall, and you really don't want to do like GPG signing with every single device and like before you can log in or whatever. So it really has to be the network. And the second thing is you have to be sure that you know what you're running. So some digital signatures. And that's what we tried also addressing in the Braiins OS firmware, because since it's following the standard OpenWRT distribution scheme, the package list is signed, obviously, and the package currently contains only a single package. It's called firmware. So if you install that firmware, it's going to upgrade your miner. If you delete that package, it's going to factory reset the miner. If you downgrade the firmware, it's going to downgrade the whole thing. So we tried like really using something that was available, but try to turn it into something that would be nice and easy to use. And for the level of security that's needed for those devices, let's call it secure.
Really interesting, and that's of course the standards of signing packages should be standard, and it's not perfect, of course. There's still some trust involved, but there are steps that makes it more trustless and more trustworthy with cryptographic certainty.
Right.
So absolutely. Well, now talking about this Asic Boost, and there's clearly a lot of stuff that has to be taken care of on the software side. But are there also changes to the hardware, and now excluding the Bitmain miners, but for example, the Halong miners with the Dragons? Do you think that there is more tech hardware level adaptation or improvements have to come in order to fully utilize Asic Boost?
Well, in my opinion, any new chips that would be entering the market should have this feature available, and this feature should be exclusively in operation. Otherwise, the design is not taking the full potential of the silicon that's like in place, right? There's one. I think there could be one exception. If you were able to manufacture many chips for really low price, that would be like really competitive to whatever the competition is doing. Then the answer could theoretically be that those chips might not have this feature. But since we're talking about those advanced technologies like 16 nanometers, which is like 2 years old, but it's still a very good technology for the chips, and going towards 10, or even some people are announcing EUV 7 nanometers, those chips definitely should also take advantage of this and share the expansion steps and really have Asic Boost in place in the chips. Because it always would be a matter of time that some other competitor would come with the same chip on the same technology with Asic Boost supported.
Exactly. And how big would the upgrade be to the hardware?
Say it again, please.
So how wide-reaching would the changes be that you have to apply to these hardware chips, and can this be done in the next generation of chips, or is more research needed?
Well, I think, or at least this is my belief, most of the manufacturers do have this in their RTLs, so the design that is not turned into silicon yet, that they can like run on some FPGA or to simulate it and verify that it works. So I'm assuming like most of the big manufacturers already have it, and they may have been delaying this until, let's say, the version rolling standard came up. And yeah, well, hopefully the next generation is like all the chips. I mean, the question is if there are any other chips out there that do have this feature that people don't know about, which would be an interesting thing to look into. So if anybody is aware of something suspicious, let us know. We may look into it.
Oh, I really like the detective work here.
Oh yeah, it's very it was very. Actually, I have a good story how this came to my mind with the S9s, and you probably are going to laugh, but I think a couple months ago we've been fixing. There were these Zcash ASICs coming to the market, and they were A9s and Z9s, and we had some problems with their support, as usual, some firmware issues, nonce sizes, and so on, as usual. Wouldn't happen with Braiins OS, I would say. But anyways, so, I mean, this is not really meant in a negative way, but I just think this is like mere incompetence in implementing firmware. I mean, if Zcash mining is supposed to look like something, and if you cannot comply with it, it's fine, but please document it, say it. Okay, we can do only nonce of this size. We cannot do anything bigger or whatever. But the problem is that you always get this device, you get this binary blob running on it without a word saying, oh, it doesn't work. So this was like one night I was digging into the Z9 issues, and I noticed the Z9 was actually trying to do something like multi-version negotiation. I was like, hold on a second. I mean, there's no multi-version anything, version rolling in Zcash. But I was thinking, oh, they usually reuse the firmwares from other devices. Like they don't really, they change the backend drivers and so on, but the CG miner is still like pretty much the same. And it just looked like that somebody just took a Bitcoin mining software and they would turn it into Zcash, but they wouldn't fix the front-end protocol. So it would just talk some garbage to our pool, and we were trying to figure out like why the hell this is not mining with us. And then I saw the full flow of the Stratum, but for Bitcoin, but this was Zcash. And when I saw the multi-version, obviously in that night we actually fixed the problem with the Z9s, but I was like, well, I may want to look into the status of the version rolling in S9s, and that's how the whole story started. So actually Zcash brought me to thinking again about version rolling on S9s. So thanks, Zuko.
Oh, so there is a use case for shitcoins. Perfect.
Yeah, well, they bring some ideas probably.
Well, really interesting. Okay, so how much time do you usually spend on improving Bitcoin software and stuff, and how much time do you spend on altcoins?
Well, we were primarily a Bitcoin mining pool. We have added a few years ago Zcash, and I think we're headed towards other cryptocurrencies. So we try to, like, currently Bitcoin is our like major source of uh, income, and also a major consumer of our engineering resources. But at the same time, we're devoting probably like 20% of our engineering resources to other cryptocurrencies, specifically Monero, Ethereum, Litecoin, and things like that.
Okay, and so Braiins OS ICO coming soon, I hope.
No, please no.
But back to the serious stuff.
I think our ICO is that people contribute with their hashing power, and we get some commission that pays for the development, and that's
Exactly.
it. That's our ICO.
You get Bitcoin. That's it.
Yeah, that's a great ICO, I'd say.
Well, and speaking about updates that are happening here in Bitcoin, especially for the mining pool side, for a couple months now, Matt Carolla, Blue Matt, has published and worked on the better hash algorithm for a protocol for client-side creation of the block candidate, so that no longer the pool operator generates this block candidate, but the individual miner itself. So I know that you've been interested in that. So could you please go a bit more into detail and what Better Hash is actually doing?
We've been talking about this with Matt for quite a long time, discussing like different opinions. I think Better Hash is intended for people who like really care about which transactions they're mining, and for people who are a bit not paranoid, but like really making sure that nothing is being censored, like no transactions are being censored towards them. We also talked to big mining operations about this, and even like smaller miners, and their feedback was it's an interesting concept, but the problem is that it's a little bit risky for us to switch the mining protocol right away for something that actually has a little bit more overhead on us if we wanted to like run it in a full mode where you really have your own work supplier that is locally deployed. Because it's actually two protocols. One is called the work protocol, and one is called the pool protocol. The work protocol provides the mining work, and the pool protocol takes care of the accounting and submission of results and counting and so on. So it's a fairly complex thing, but we're actually looking into it more deeply because we really like some of the concepts where, for example, it takes care of the authentication problem with Stratum. That you technically you authenticate with a pool, but nobody ever checks the integrity of the data that's being sent back and forth. So Stratum is very it's not resistant towards man-in-the-middle attacks. And this has been addressed in the Better Hash protocol. So this is definitely a good inspiration for the future, what to do with it. But yeah, we'll see what we can do with it in the future.
Would Better Hash in any way or help against the 51% attack?
I don't think so. I mean, technically, if you own enough hash rate, it does. It's independent of the protocol, right?
Well, yeah, true. We have seen in history that a couple mining pools got close or even overstepped the 51% accumulated hashing power. So in that situation where a mining pool controls 51%, would a mining pool that is operated with the classical system be any more susceptible to malicious attacks by the mining pool than a network that would be run on the Better Hash protocol?
I think it's a difficult question for me. I have no good answer for this. Like my non-technical view, and really, I probably don't see all the uh, all the impacts, but I just don't think. I think it's the same. It should not really matter, but don't take this like seriously. We can talk embedded hardware here. We can talk Asic Boost, but like this is not like my major area of what I can explain or give
Well,
some
yeah.
good advice.
And that's the crazy thing about Bitcoin, is that no matter in which topic, you never know everything.
No, no, no way. Same thing like with the SegWit and the commitment thing. This is something that I studied from like 2 years ago, and it's so easy if you're not really deep into it for a long time. You forget like all the tiny details.
Exactly. That's why it's good to have specialization and
Right.
and to have experts, so to say, working in their niche subject. Absolutely. So yeah, let's get back a bit to ASIC Boost, and especially on the hardware side. So is there or what specific improvements are you looking forward on the hardware side for the miners in future generations? Because we have seen that Bitmain, for example, has been struggling with producing, quality hardware that is actually efficient. And I think the S9 is now already 2 years old, so it's no longer the most new and useful hardware. So where do you see any interesting improvements coming in the hopefully near future?
Well, I've studied a little bit the nanometer technologies that are being currently used in the present process nodes or the fab houses for chips for wafers, and I think what the future should bring is a significant reduction in costs. The cost for producing the chip is pretty much determining the price of the mining hardware, right? So what you're trying to achieve is some balance between the cost and the performance that you can take from the chips. For example, the M10s that are coming out, or probably these days, they're not using some super new nanometer technology. I think they're running at 16 nanometers, but they're using more chips at lower speed with higher efficiency. So they probably achieved the ultimate goal of producing chips at lower cost than the competition is doing. And that way they can put more chips into the hardware and sell it for some competitive price. So I think the future is further reduction of the cost. I'm assuming also there's going to be or there could be some change in the form factor of the miners, because when you look at today's miners, they are not very efficient in terms of total cost of ownership. Like the retail miners that are being sold, it has been like one box with 3 or 4 hash boards for ages. So that means you're paying for all the cabling, you're paying for the control board that could theoretically control more than 4 hash boards. So the form factor is definitely going to change. I think Bitmain is coming out also with some water cooling alternatives, which may sound pretty cool. I'm not sure like if this is like the best solution that you can have in your mining farm. And one big expectation for me is this EUV thing, which is the extra ultraviolet lithography that's coming to 7 nanometers. Like when you were mentioning the 7 nanometer technology that many manufacturers have failed, the problem was that the standard lithography process that's being used for bigger chips than 7 nanometers is a big, I don't want to call it a cheat, but it's a trick. It's an optical trick. So the wavelength of the light that's being used to light up the mask and then produce the chips is significantly bigger than the width of the path on the resulting chip. So let's say if you have like 10 nanometer path on your chip or trace or whatever they call it, you need something like 150 140 or 190 nanometers of light, and quite a few optical tricks to get to this size. And this was working fine up to 10 nanometers, but with 7 nanometers, this started being very tricky, making the manufacturing process consisting of like many steps, which have a tremendous impact on yield. So even if AMD or Intel are announcing they're producing 7 nanometer chips, it's fine for them, because I mean, how many chips do you have in your desktop? It's probably one, right? It has 4 or 16 cores. But here we're talking about hundreds of chips, each individual chips packaged in a single package. So if you have big variance in your manufacturing process due to a complexity of running many manufacturing steps in the fab house, that makes it very difficult to assemble a miner. So I'm very curious when there's going to be a company producing 7 nanometer miners in a mass scale. I'm sure there are some companies that produced 7 nanometer chips and produce some prototype miners, because they were able to run a big batch through the fab house of test chips, and they would select, I don't know, a few hundred chips out of this test batch. If they had like 30% yield, that's fine, but you cannot make a commercial product with 30% yield. But with the EUV technology, which is the extra ultraviolet, which is I think it's like 90 nanometers, just don't take me literally, but you can Google it. So the reduction of the wavelength is so significant that the efficiency of the process is much higher. That means the yield ratio is better. It also has less manufacturing steps. And this would be the future for better technologies than 7, or from 7 and up, or actually 7 and down. So I'm very curious about this development. And obviously, also very curious when this development is going to be converted into cheap chip production. Hopefully I didn't branch off too much of your topic, but...
Oh, no, perfect. That's exactly what we're doing here at the World Crypto Network. It's just talk about whatever interesting comes up. And that's really cool what you bring up. So do you think that these types of really new advancements will first be used in consumer-grade hardware, like CPUs, or will it be specifically maybe targeted to ASICs first? So do you think that ASICs will be the forerunner of this new technology?
You mean like mining chips? Actually, the mining chips for Bitcoin, I think, are very simple circuits compared to your CPU on your mobile phone. However, when I read about the EUV announcement, I think it was TSMC announcing it a few weeks ago, they basically claim that they have produced in a large scale a 7 nanometer SoC, so system on chip, for an undisclosed vendor. But it just sounded like a CPU or something like the SoC. But at the same time, they were saying that they already work on 5, and this should be a further advance in EUV thing. So this proves that they didn't produce a mining chip. But what I'm trying to say is that we're in our own bubble, right? So we look at the mining and so on. So, I mean, the question is, if you look from a global perspective, if TSMC announced on a global level, okay, we have made some hashing chip on 7 nanometers, do you think that the big vendors would actually care to give them some orders? Because, I mean, the chips are really dramatically more simple than CPUs. So I think a lot of this information goes sort of like, under the line, like they don't talk about it too much because it doesn't have that big impact for them. So maybe it's also a nice test bench for them, because producing some useful chips at that technology, which obviously the mining chips are, could prove that the technology works. So maybe we could be getting mining chips sooner than CPU manufacturers and iPhones and stuff like that.
Cool. As always, Bitcoin is driving innovation. And I think we see that on so many scales, especially in mining, where efficiency is extremely rewarded, right, with a lot of additional profits. So this additional financial reward is just another incentive of improving better chips and cheaper electricity.
Yep.
So that's amazing. The positive externalities of Bitcoin mining. It's beautiful. So do you think that then there is an end to Moore's law, or does it seem that every time that we kind of hit what is perceived to be impossible to further improve, there's always new improvements coming? Will we have negative nanometers soon?
There would be like black holes or something like that, like micro black holes.
Black holes in the computer chip. Why not?
I don't know. I think, well, 0 is 0, right? And we still have 6 to go. If we're at 7 and people start talking 5, I think what's going to happen next is people will try to make bigger chips, running more things in parallel. I think Intel already is, they do 3D, right? Like for now, the chip is still sort of like a multi-layer PCB, and they could do some more advanced structures probably in the future. But it's in a way it's already 3D. So I mean, I don't know when people talk about 3D chips what they really mean by that, but I kind of see like really multiple chips on top of each other, try to build, I don't know. So I think the future would be like parallel way. Like this is what's happening in the CPUs already, right? Nobody's using like single core. We use like 16, 8-core CPUs in our desktops. This is how the mining chips are actually designed. Like the chip itself is not a single core. It contains like tens of hashing cores already. So I think the one way of doing it is that the chips would start getting bigger. The problem is that always the packaging is so expensive, so it will be a balance between the manufacturing costs and benefits. Like if you integrate in a single chip, or if it's cheaper to put more chips on a bigger PCB because PCBs are more simple and cheaper to produce. That's the thing. I mean, maybe one day chips will be so cheap to produce that you will not have like really any complex PCBs, but everything would be on chip. I don't know.
Curious. So, and that's something that that I talked with Peter Todd about at the Hackers Congress, is the question of if we can bring decentralization in the most extreme sense to the Bitcoin chip manufacturing, or chip manufacturing in general, by technologies similar to 3D printers. Really extreme local production of the chips. Do you think that that is ever possible? Maybe not with 3D printers, but maybe some biochemical stuff.
You mean instead of doing like a standard lithography, but trying to do it sort of like nanorobots, like really printing the chips? I never thought about
it. Like on your desk, might be cool.
3D printer for a chip. Yeah, well, have you ever been to like a chip manufacturing house or a mask house? It's really impressive, and when you see it, you sort of start thinking a little bit, down the earth, like not making big things up. So when you see what we can print with a 3D printers, I think we're gonna have like artificial organs sooner than like being able to 3D print chips. The lithography still seems to be the way to go, but maybe we'll hit some limit and we will we'll have to start thinking how to do like 3D printing with electron guns. I don't know.
Well, and the inevitable end game is, of course, space pirates building a Dyson sphere around the sun and 3D printing their own Bitcoin miners next to it in space. So that is the clear end goal, and we all should strive towards that.
Oh yeah, I'm looking forward to that.
You mentioned previously a little bit about water cooling, and that is quite interesting because especially with larger farms, right? You generate a lot of heat. Mining, it really is energy intensive, and therefore heat is generated. And cooling this equipment down is one of the other big costs, operational costs other than electricity. So are water-cooled chips potentially really interesting for a decrease in the operational cost of mining?
When you look at some numbers, currently, let's say from 1450 watts miner, the fans take about 50 watts, something like that. Depending if you have some speed control or if they're running like full speed all the time and so on. But so out of 1400, you have something like 50, which is under 10%, right? It's about 5%. So I think people will start looking into those topics, like seriously looking into those topics, once we hit some profitability level. You know, when miners start being break even, they will start thinking like trying to save every single penny. But for the time being, what we saw with the big farms, and we discussed this, they all said like, well, we had some prototypes how to do like liquid-based cooling. Let's not call it water cooling, because water cooling is a little bit more hardware intensive in terms it requires special setup. Like when you want to cool your PC with water, right? But an interesting area is actually using immersive cooling, where you put the whole miner, obviously without the fans, into some liquid that can take away the heat, and then you can use some radiators to extract the heat or use the heat in a more efficient way. But what I was going to say, that the farm said that they did all this research and they have some prototypes, but at the end of the day, for them, with the current technology and with the Bitcoin price and with the availability of the hardware and so on, it is the most economical way. Just suck some air in and put some hot air out with fans. And on a large scale, the amount of energy, because obviously they don't only have the small fans of the miners, but they also have some air pumping system with bigger fans, like pushing air into the facility and then sucking the air out. They basically said that for now, this is the best way of running the operation, also in terms of maintenance and cost of maintenance.
And then cost is, of course, the driving force in mining, right? It is the aspect of do you still retain money, and do you think, or are you losing? And especially during a bear market like this one, you really see it, where miners are struggling because of the price of Bitcoin, of course, decreasing. So you like being locally at the source. How do miners experience this type of not really prolonged bear market, but definitely a consolidation?
Well, some miners are already on the break-even level, so they are surviving, but they're struggling or basically speculating that the exchange rate would recover. But I think most of the miners are still not there, so I think they're still profitable in a way.
Yeah, and we've seen that with the immense increase of hashing power still.
Yeah.
Although the price was going down, hashing rate just keeps on increasing, which is quite insane.
Actually, I didn't do my calculation lately. If you have, I have a guest on my GitHub that actually, I mean, there are many calculators out there, but the reason why I made it a guest was that I wanted to publish the physical Python snippet that would show how you can estimate the cost for mining one Bitcoin with an average mining equipment, which I think I used an S9 for that. I can quickly redo it, or I can send you the link after that. Last time I did, the costs were at like $3,000 for one Bitcoin with like 5 cents per kilowatt hour. People would start arguing with me like, oh, this is not like the full cost, but I was like, well, for my estimate, I took like 5 cents and included like all the operational costs, because I mean there are facilities out there that are able to buy the electricity much cheaper than this, and with the operational costs that are in terms of stuff that you have to have on site and security and the network infrastructure and so on, it adds up to this value, to this value roughly. So this is it.
Really nice. And do you see a overall tendency in the market to either more centralization or decentralization? Just a macro tendency.
What I think what puzzled me in the past more was that there was a centralization in terms of the number of manufacturers being able to produce the hardware. I think this is changing lately, and once we have at least a little bit of diversity, it is good for the network. Obviously, the hash rate is going to get concentrated in a bigger farms, but at the same time, there's like so many big mining sites already that I'm not that much worried about like the full decentralizations. Like, you know, some people get very annoyed by the fact that we still have this proof of work that allows producing ASICs, although we should change it. But the problem is that whatever you change it to, sooner or later somebody is going to come up with an ASIC, but the ASIC is going to be more advanced than the one before, which is going to build up even bigger barrier for new manufacturers to enter the market. With the current proof of work, we have a relatively simple proof of work algorithm which allows producing relatively simple chips. The only problem is that obviously the technology that you need for the chips, so the fab houses, are already the cutting edge technology in the IT industry. So that's what makes it expensive. But if you think a little further, with a different proof of work, we would probably hit this edge as well, but we would have even more complex hardware. Whereas the current hardware that is built around the chip is very simple. It's usually just some communication device talking to the chips. Pavel just told me we're going to deploy the patch for the Stratum servers.
Oh, very nice! Right now.
Yeah. So we have some hours ahead of us to get this ready.
Well, that is both good news and that this patch is coming out as fast as possible. And then I guess you got to get going and actually get some work done.
Oh yeah. I think so. I'm going to join the team for the deployment as well.
Well, perfect. That is good because we need people like you actually sitting your ass down and writing the code and deploying it, and not just talking about it. That's the boring stuff.
It's actually the team that wrote the code. I was sitting here talking to you, but yeah.
Well, cool thing that you have such a dedicated team working on it. And yeah, thank you very much for joining us.
Well, thanks for having me here.
It really was we talked about a lot. It was really good. I mean, of course, we talked about Braiins and especially Braiins OS, the operating system, which found out that Antminer S9 actually can have avert Asic Boost, and which they are going to enable because open source everything. And that gives you 30% more power savings, which is nice. So be more efficient. Read that article. It's really good. It really explains everything well. And then read from Bitmain their hilarious counter argument and now hastily releasing of the one part of the code that makes this whole thing so interesting. And don't upgrade your nodes yet. Wait for the patch.
Yeah, we'll let you know.
Piers, thank you so much for supporting the World Crypto Network. I'm excited because we have broken the 0.3 Bitcoin funding goal. And that means, my friends, that we can get the Purism laptop, open source everything, as we like to say. So that is amazing. Thank you so much for your donations, especially the fact that how many were there? Like 31 donations. So that's amazing. Thank you so much. We can get our hands on the amazing Librem 15, which is really cool. And I'm really looking forward to hopefully lots of in-depth reviews of this amazing open source hardware. So Piers, it's been a pleasure talking to you again. I learned a lot. I hope you did too. Thank you, Jan from Braiins OS, to joining us. That was very kind of you for dedicating your time. And keep on
Anytime.
working the good fight.
Yep, bye.
See you, my peers. Bye-bye.